Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is video to discuss about the answer for the pre-quiz questions given to you. So if you have not yet done answering the pre-quiz, so I advise you to finish your pre-quiz first and then come back here to check your answer. Okay, for question 1a, find an expression for m minus 1. Okay, means m inverse. So for 1a, so we take m x equal to 1 plus x square over x square. So we make it x equal to 1 plus y square over y square. So it will become y square x minus y square equal to 1. So I can factorize out y square, and I have x minus 1 equal to 1, and I have y square equal to 1 over x minus 1. Okay, then we can bring the square onto the other side and it become a square root 1 over x minus 1. So then I just change back my y in the form of m inverse equal to square root of 1 over x minus 1. Okay, then next, to find the domain and range for mx and m inverse. Okay, for question B, find the domain and range for mx and x inverse. Okay, the question has already mentioned to you that the value of x must always be bigger than 0. So means there are no graph in the region where x is a negative. Okay, state the domain and range for mx. Okay, then our function for mx is equal to 1 plus x square over x square. So since our numerator is quadratic, because we have x square, so for a quadratic it will be from negative infinity until positive infinity. Okay, but then our denominator says that x square cannot be equal to 0. So x cannot be equal to 0. So our domain for m will only cover from 0 until positive infinity. Okay, then to find the range, I will just use the inverse of the mx. M negative 1x equal to square root 1 over x minus 1. Okay, from this mx inverse, the denominator mentioned that x minus 1 cannot be equal to 0, so x cannot be equal to 1. So we have x cannot be equal to 1, and then we know these fractions are inside square root. So anything inside square root must always be bigger than or equal to 0. So we have x minus 1 bigger than or equal to 0. X must always be bigger than 0. Sorry, since the x minus 1 is at the denominator, it cannot be bigger than or equal to 0. It must be bigger than 0. So then we have x is bigger than 1. Okay, we have x is bigger than 1 like this. So from the inequality, we know that we have 1, and our region for domain for m inverse is from 1 until positive infinity. Okay, so back to the theorem of the concept of inverse function. The domain of the inverse will be the range of the original function, which is 1 positive infinity, and the domain of the function m will be the range of m inverse, so 0 until positive infinity. So that is the answer for domain and range for function m and m inverse. Okay, then for C, in order to sketch the graph, okay, in order to sketch the graph, first make sure that you label the axis, x and y axis. Okay, and then you label the asymptotes. For example, we have asymptote at x cannot be equal to 0. Okay, x cannot be equal to 0. Right here, x equal to 0. And then for the function m has range that start from 1 until positive infinity. So that means we have another horizontal asymptote at line y equal to 1. Okay, so our graph for mx, since this is a rational function, so the graph will be shaped like this. So it never touches the asymptote, and there is no graph in the region where x is a negative, because the question mentioned that x must be bigger than 0. Okay, this is for graph mx. Okay, then for m inverse, so m inverse has the asymptote of domain, since the domain mentioned is from 1 until positive infinity. So then our asymptote is vertical asymptote is at x equal to 1. Okay, so the graph for inverse function will be shaped like this. So okay, so to check whether your answer for inverse is correct or not, or your graph is correct or not, you can draw the reflection line where y equal to x. So you can see the inverse is the reflection of its original function. This is m inverse. Okay, so that is how you sketch the graph of mx and m inverse. Okay, now let's go to question number 2. Okay, firstly we have to sketch the graph of hx. So we know that hx is a function. Okay, it consists of rational, modulus and quadratic. So we label the y and x axis. Okay, don't forget to label the x and y axis. Okay, so firstly we have hx 1 plus x plus 3, 1 over x plus 3. So 1 over x plus 3 in the region where x is less than negative 3. So from the rational function we know that x plus 3 cannot be equal to 0. So x cannot be equal to negative 3. So we have the asymptote right here at negative 3. So first we draw the asymptote. Okay, so then we sketch the graph. Okay, the graph will be shaped like this for a rational function. Okay. Okay, then we move on the second equation, which is the modulus of x. So modulus of x will be equal to positive and negative x. So it lies in the region in between negative 3 and 2. So 2 might be around here lah. So we label that as 2. Okay. So a modulus will always in the shape like this, kan? Like a V shape. So the region mentioned is not equal to 2. So make a hollow circle right over there. And it must be equal to 2 right here. And for 3 must be here. So for 3 it is bigger than or equal to negative 3. So must be a bold circle. Okay. Make sure you draw a straight line. Mine is not straight enough. Okay, that's one better lah. Okay, so this is the shape of the modulus. And then finally we have x square. x square, where x is bigger than or equal to 2. So it must start from x equal to 2. So let's first substitute. If we substitute h2 equal to 2 square, okay, it will become 2 square and it will be equal to 4. So that means when x is equal to 2, so our graph must start at 4. Okay, shape like this lah. Okay, because it is x square, so must be in the shape of quadratic, something around like this. So I just continue from the region where x is bigger than 2, but you don't need to draw other than the region less than 2. Okay, so this will be the shape of the graph for hx. Okay, and then the question 1, to determine the domain and range for the hx. So that is for A and this is for B. Okay, to determine the domain, domain for h will be equal to, you can see here on the left side, the graph comes from negative infinity and it goes until negative 3. We have an asymptote at negative 3, but we can see that the modulus function, okay, modulus function continues right from the point of negative 3, go to 0 and go to until positive 2, but it does not equal to positive 2. But don't worry, the function of x square, continue from the point of 2 and go until positive infinity to the right. Okay, so that means our domain will be from negative infinity until positive infinity. Okay, for the range of h, we can see the lowest point is from the negative infinity, that covered by the rational function negative infinity, and it goes into the asymptote of 0, but 0 is covered by the modulus function, so it includes the 0. Okay, then it extend until y equal to 3. Okay, y equal to 3 with a square bracket. Okay, and then we have a gap. Okay, we have a gap right here in between 3 and 4. There are no any graph within this region, so we have to put union, then we start back from 4 until positive infinity. So that will be the answer for the range. Okay, then for C, determine whether hx is a one-to-one function. Give a reason to justify your answer. Okay, hx is not a one-to-one function. Not a one-to-one function. The reason is that the value of x in between, okay, the value of x in between negative 2 and 0, okay, from negative 2 until 0, which is from here, negative 2 until 0, share the same value of y with the x in the region between 0 and 2. Okay, 0 and 2 is right over here. Here is negative 2, 0, and here is 0 and 2. So we can see that they both share the same value of y. So we can know that this is not a one-to-one function. So that is the solution for the pre-quiz question that I gave to you. So, good luck.